I'm sure you have seen the plots of CO2 increasing, especially from the 1950s. Now, every day we talk about what the concentration of CO2 in the atmosphere is, and so on. So, now you're asking me, who started measuring this, right? So, this is called the breadth of the earth. So the birds and butterfly and the turtle are going around looking for fresh air. So here is Mauna Loa in Hawaii, which is out there in the North Pacific west coast of the US, far away from Japan and quite far away from the US as well. It's a volcanic island, and it's a place where CO2 started being measured. And how did it happen? One fine day in 1958, the American chemist Charles Keeling drove up Mauna Loa, a volcano in Hawaii. It was quite a climb through a bare landscape of solidified lava. As I said, it's a volcanic island. The research station where Keeling was going to work was at a height of 3,397 meters. So let's say about 3,400 meters. You multiply it by about 3 and you get the number of feet, if that's what you are used to. He was going to measure how much CO2 there was in the air. It was the ideal spot at that high latitude, far from civilization. The air is nice and pure. That was why astronomers gazed at the stars through the telescope on a nearby volcano, where factories and traffic jams did not get in the way of going out of the atmosphere into space. There was no light pollution, dust pollution. This was a good thing for Keeling too, as the amount of CO2 in the air has to be measured very accurately and not locally near a factory. It may be all related to the factory. In a traffic jam, it may be related to the local traffic, but way out there in the mountain in the middle of the ocean, it is what the atmosphere has by mixing everything. What is not mentioned here is that at that time Charles Keeling was a graduate student. In India we say postgraduate student, which means he had finished his undergraduate degree and he was trying to get a PhD, which means he had an advisor, and his advisor was a guy called Roger Revelle, and they were both at the Scripps Institution of Oceanography in La Jolla, California, on the west coast of California, southern part of California. Roger Revelle was an expert in the ocean and how much ocean CO2 is changing, and why it is there, and how it dissolves, and why it is not saturated. A lot of very interesting work he was doing. Then he told his graduate student, well, you go start measuring CO2 in the atmosphere, because I suspect it is having some interesting signal related to human activities. When Keeling began, there were 315 particles of CO2 to every million particles of air. If you capture a million particles of air anywhere in the northern hemisphere, approximately 315 particles at the time were CO2. Very small part. Hence, this is why CO2 is called a trace gas, and if you do the calculation, that turns out to be about 0.04% of the concentration of the air is CO2. The rest was made up of nitrogen, oxygen, and so on, that you already know about. So how did he know that there were 315 particles per million? He had to pump the air through a device with a special lamp. The lamp emits infrared radiation, just like a TV remote control. You press it and the channel changes, right? You don't see any signal going, but it's infrared, so we cannot see it, just like the heat coming from our body or the heat going to space from Earth. Right? So the more CO2 there is in the air, the more radiation is blocked, because CO2 is a greenhouse gas. It doesn't allow, stop the visible light from the sun coming through, but if you send infrared light, it will block some of it or most of it. More there is, more it will block. Right? A meter on one end of the device checks to see how much infrared is left when he shines it from one end of the pipe. That's how they measure the amount of CO2 in the air. This method also works for methane and other greenhouse gases. Okay, so here is a nice plot. He started in about 1956, I think. You can check. This is the number of CO2 particles per million of air particles, so we call it ppm, parts per million, and the numbers here going from 315 to now more than 400, because when this book was published this was still under or just about 400. Now every year we are increasing it, so from 1956 or so to 2015, 16, 17, you can see CO2 is increasing, but it's going up and down every year. So here is in November it's maximum, so it's going up, and by May it is going down and then going back up again. Why is this doing? In a year it's going down and coming back up. I think you know. After a few years of measuring, Keeling discovered two important facts. The CO2 in the air changes according to the season. From May the amount of CO2 drops, and from November it increases again. What Keeling was seeing was that the breeding of the plants on Earth was causing this outgassing. And what do plants do? They take CO2 and they do photosynthesis, which means they take it away. When fall and winter months come, the leaves fall on many trees and light goes down, the photosynthesis becomes less and less, so plants now are breathing, so they are mostly not taking up CO2, but just like everybody else they are also giving out CO2, because everybody has to breathe. Plants are living things, they have to breathe, right? In the north, so this is what Keeling was seeing. What Keeling was seeing was the breathing of the plants on Earth in the northern hemisphere, to be precise, because there is much more land in the northern hemisphere, so more plants grow in the north than in the south of our planet. In springtime the plants shoot out of the ground and absorb a lot of CO2. In the fall lots of plants die or drop the leaves and everything starts to decay and the CO2 goes back into the air. A graph can show how the amount of CO2 per million particles of air goes up and down in a wave. 315, 16, 17, 316, 15, 14, and so on and so forth. So it's some years it's not going up as much, some years it's not coming down as much. It could be a drought and many plants may have died. It could be a wildfire. There could be more going into the ocean, and so on and so forth. If you look closely at those figures, you can see the second important discovery that Keeling made. The peak of the waves is a little higher every year. In 1958 he measured an average of 315 particles, not 56, 58. 315 particles of CO2 per million. In 1959 it was 316. In 1960 it was 317. Already way back when it was increasing a little bit. Every year it went up by an amount of 1 particle per million, and this increase began to get larger and larger. The levels of CO2 are still measured on Mauna Loa today, and now the number of particles of CO2 in the air is increasing by more than 2 parts per year. In fact, now in 2024 it's increasing by about 3 to 4 particles per year in a million particles of air. So as a result, on May 9th, 2013 we passed 400 particles per million for the first time, and that figure just keeps on rising. For the first time you can think of as since Industrial Revolution, but now we have data going way back and we now know that we are higher than in the last several million years. Okay, so here's Charles Keeling, who went from 1928 to 2005, a chemist. His son Ralph Keeling is now at the same institute, Scripps Institution of Oceanography at La Jolla, and Ralph continues to measure CO2 just like his father, but he's also measuring oxygen, because if you're increasing CO2 like this by burning fossil fuels, coals, petrol and gas, then you're also using up oxygen and decreasing oxygen. But nothing to worry about. There is a lot of oxygen on Earth and we will not have any trouble breathing, but pollution makes it difficult to breathe, right? So Svante Arrhenius would be happy to hear that there is so much CO2 because he wanted Sweden's climate to get warmer. If his prediction is correct, it means that temperature on Earth should go up as well, right? Is it doing that? Of course we can measure now directly and we know that it's going up, but how do we know for how long it has been going up? For that we'll have to go back in time again. We talked about various ways in which we do that, so we will talk about the growing hockey stick. This has a little background and we'll see what that means in the next podcast, but we'll come back and talk about the hockey stick. Here for Indians the hockey stick is slightly different. We have a like a curved hockey stick, but in the US this is how they play ice hockey, and this is how the hockey stick looks, which means it's flat and it suddenly shoots up on one end, with which this player who's wearing his helmet and his skates, and here is a hockey puck and he's on ice and he will go around dribbling the puck and shoot it into the goal or try to beat the goalie and put it into the net and so on. So you get the idea that the CO2 measurement started directly from the air in 1958 by Charles Keeling, and now it continues with many people making the measurements, but his son Ralph Keeling continues as well. This has become an iconic figure and every day we can go and look at it. If you Google CO2 now, you will find a website which will show exactly what the CO2 concentration in the atmosphere is today or yesterday, okay? And there are many details which we'll discuss as we go along, okay? That's the CO2 measurement. See you now in the next podcast about measuring temperatures and where this hockey stick discussion comes from. We'll see that, okay?